this video we're going to discuss about roots of polynomial equations. Okay, so this is going to be our takeaway later on, but then let's not concentrate here first, but I'll give you first some example so you would be able to understand what does it mean. So let's have a review of your A level first in quadratic equations, solving quadratic equations. In solving quadratic equations, you have learned that you can find actually the roots of all of this equation. So the first one is that if you take the roots of this, it will give you can actually factor it out by x minus 2 times x minus 5, and that's equal to 0. And the roots equals x equals 2, and the root is x equals to 5. Now, I would like you to look at this one. If you take the sum of x1 plus x2, what do you have? So that is actually 2 plus 5, which is equal to 7. If you take, for example, the product of the two, when you multiply them, so that is actually 2 times 5 is equal to 10. But then, please take a look at this one, that this 7 here is actually this part. This 10 is actually that part. So basically, this one here, okay, this one here can be written as x squared minus the sum, then you have the x, right, plus the product, whatever the product is, and that's equal to 0. And that is a very important concept in further mathematics, which we're going to explore. So let's look at the next one. In here, you can factorize this as x plus 3 times x plus 1 is equal to 0. So the roots are x minus 3 and x minus 1. Let's take the sum of this. Negative 3 plus negative 1 is negative 4. And this is now the product. x1 times x2 is negative 1 times negative 3. So negative 3 times negative 1, which is equal to 3. Again, please notice something. The 3 is the product. Look at that. Plus the product. The minus 4 is the sum. So this part here is actually the same as minus of negative 4. See? And as you can see, if you can rewrite that will give you x squared minus the sum of x plus the product. That's equal to 0. Take a look that this and this are the same. Okay? But please take a look. Let's look at this example number 3. In this example number 3, as you notice, there is a number in front of x squared. Unlike our first example, there is none. First example, there is none, only 1. But this one has 4. Okay? So let's try to solve this one. When you factor this one, that will give you, it should be 4, but 2x, okay. I think, when you factor it out, that will give you 2x, 2x minus 1 times 2x plus 3, and that's equal to 0. Is it right? Yeah, that is actually correct. And it will give you the roots, x equals 1/2, and x is equal to negative 3 over 2. Please take a look of what's happening. If you take the sum of the roots, it will give you 1/2 plus negative 3 over 2 is equal to negative 1. And then if you multiply them, it will give you 1/2 times negative 3 over 2 equals negative 3 over 4. So as you can see from here, this is now the sum and that is the product. But let's try to look at here. We cannot find it here. But look, if I will divide all of this by 4, this one will be transformed into, I will transform this, okay? I will write on top, x squared plus 4 divided by 4, 4 divided by 4, right, is 1x minus 3 over 4, and that's equal to 0. And please take a look. Negative 3 over 4 is the product. It's still there. See? Negative 1 is your sum, and that is actually here. There's one there, minus negative 1. So basically what am I trying to say is that in these three examples, we have proven that this is true. That x squared minus the sum of the roots, x plus the product is equal to 0. Okay, and that is very, very important. Now, that is the A-level part. Let us now proceed to the further mathematics part. But before this one, my dear, please take a look of the following notation. Okay, you need to be careful of the following notation. This one here, this one, we will use the notation sigma alpha. It's so ugly, but I will just say sigma, meaning the sum, alpha stands for the roots, okay, and that stands for x1 plus x2, right? The product, x1 times x2, we will write that one as sigma of alpha beta, all right? Okay, so again, this one, x1 plus x2 is sigma alpha, where alpha and the beta are the roots. But please take note, this sigma alpha, meaning to say sum of all the roots. Sigma alpha beta, sum of the product of the roots. Okay, so that's the meaning of that. Sum of the product of the roots. Okay, please take note of that, of that notation. I think just to make it clear, I will write it in English form. Okay, that the sigma of alpha is the sum of the roots. The sum of all the roots. I will put the word all, of all the roots. Okay? While the symbol sigma of alpha beta, meaning the product, how come I forgot the word sum? The sum, because this one means sum, okay, that's sigma notation. The sigma or the sum of the product of all the roots. Okay? Please put this one into your head. Alright? Put this into your head. And every time you see this symbol, that is the one that you're gonna think. Okay? So, what about like this? Sometimes you will see in your exam, what is the meaning of sigma alpha squared? What do you think is the meaning of that? Okay? So, the meaning of that is the sum of all the square of the roots. Meaning to say, if x sub 1 is the roots, x sub 1 squared plus x sub 2 squared. Okay? So, it's just like that. So, these are the stuff that you actually need to know. But before I proceed to this, let us try to have some example of the application of this. Okay? Let's try to have some example of the application of this. I think I'm going to take this. Okay? I'll erase this one. It's not yet needed. So each of the following quadratic equation has roots alpha and beta. Find the values of alpha plus beta and alpha beta. Okay, so in this case, because there are only two, we're using the symbol. Okay, but again, later on, we're going to use this, sigma alpha beta. Okay, now, the sum of the roots is what? For the first one is negative 5. Negative 5 is the sum. Or we can say that the sum, sigma alpha is negative 5. Okay, now, the product of the roots, sigma alpha beta, or just the product then, is equal to what? Wait, I will not use that notation yet. I will use that one when we proceed to cubic function. So alpha beta from here is equal to 9. So this is your number 1. Okay, 1a. For 1b, what is that? So again, you check that, it's x squared, so no problem. So therefore, the alpha plus beta, sorry, there's a wrong notation there. Alpha plus beta is 4. Okay? Again, minus the sum. So it's minus 4. So the sum is 4. And then alpha times beta is equal to 8. In this one, in letter C. So again, rewrite it first. X squared plus 3 over 2x minus 7 over 2 is equal to 0. And then what you're going to do next is alpha plus beta. is equal to negative 3 over 2. Okay? And alpha times beta is equal to negative 7 over 2. So basically, that is the answer. That is the application of what we have just learned. Let's try to look at question number 2. Given that 3x squared plus 4x plus 12 is equal to 0, has the roots of alpha plus beta. Find alpha plus beta and alpha beta. So again, in that one, number 2, just divide everything by 3. Then you will have this is equal to 0. So therefore, the alpha plus beta is equal to negative 4 over 3. And the alpha beta is equal to positive. No, wait, why did I write 12? Positive 4. Okay, that one there. Positive 4. Okay, next. Now we have a problem that, look at that one. This is the one that I've just written a while ago. What does it mean? Okay, that means that square, the sum of the square of the roots. See, imagine, we're not finding the roots, but we can actually get the sum, we can get the product, we can get the sum of the square of the roots, which is actually good. So, that is now the problem. How are we going to find alpha plus beta squared? And this is the trick for this one. So, you ignore that question first. You need to ask yourself, how can you obtain this expression? We can obtain that expression. We know that, let's say, alpha plus the beta. And then you square them. What will happen? That is actually alpha squared plus 2 times alpha beta plus beta squared. Okay? And what do we know? Alpha plus beta squared is equal to alpha squared plus beta squared plus 2 alpha beta. But what do we want is only this part. We want only that part. So therefore, what we're going to do is that you have the alpha plus beta squared minus 2 alpha times beta is alpha squared plus beta squared. And then now we are ready to find the answer. Why? Because we know the alpha plus beta is negative 4 over 3. So negative 4 over 3 squared minus the product is equal to 4. 2 times 4. And that's equal to alpha squared plus beta squared, which gives you 16 over 9 minus 8 is equal to alpha squared plus beta squared. Okay, so, and just simplify that. So 16 minus 72 over 9 is equal to alpha squared plus beta squared. What is 16 minus 72? 56 over 9, is it? Yes, 56 over 9 is equal to alpha squared plus beta squared. That's it. So that's how we gonna answer this type of question. There's one more question here which I really want to solve. Okay, guys, if you got confused with this topic, with the explanation, just try to watch the video again. Okay, try to rewatch the video again. I'll just finish to answer the last question, and then I'm gonna proceed to generalizing everything, or the cubic function will be the next one. Okay, so let's have this. X squared is equal to negative 2 alpha plus 7 plus p is equal to 0. Has the roots differ by 1? Find the value of p given that p is greater than 0. What is the meaning of this? We know that alpha plus beta, the sum, is equal to 2 plus p. That's what we know. And we know that alpha times beta is 7 plus p. But then, there is a clue that the roots has the difference of 1. Meaning, if one of the roots is alpha and another roots is beta, the beta could be alpha plus 1. Okay? Because the difference is 1. So therefore, from here, we can use this equation 1. By substitution, that will be alpha plus. You plug in this one because that is your beta. Okay? Your beta is alpha plus 1. That is your beta. Okay? Is equal to 2 plus p. And let's just simplify further. That one will give you 2 alpha minus 1 is equal to your positive p. Let's take of these. Mr. Daniel, why do we need equal to P? Because P is the topic here. So we need to write an equation in terms of P. Okay? So let's look at now the alpha beta. So definitely the alpha, we have now equation number 2. Alpha is equal to what? Alpha plus 1 here for the beta is equal to 7 plus P. And take a look. Alpha squared plus alpha is equal to 7 plus P. And what is the P? Alpha squared plus alpha minus 7 is equal to P. This is now your equation number 2. And this is now the magic. The P is equal to 2 alpha minus 1. The P is equal to alpha squared plus alpha minus 7. Because both of them are equal to P. Then 2 alpha minus 1 should be equal to alpha squared plus alpha minus 7. Right? And now we can get a quadratic equation. We can now solve it using quadratic equation. That will give us alpha squared plus alpha minus 2 alpha minus 7 plus 1 equals 0, which alpha squared minus alpha minus 6 equals 0, which will give you alpha 3, 2 minus plus equals 0. So alpha is equal to 3, alpha is equal to negative 2. But the question is, what is the P? And take a look, there is a condition for the P, that the P is greater than 0. So from equation number 1, the P is 2 alpha minus 1. Since the P is equal to 2 alpha minus 1, so the P now is equal to 2 times 3 minus 1, which will give you equal to 5, which is greater than 0, right? Well, if alpha is negative 2, therefore we have P is equal to 2 times negative 2 minus 1, which will give you negative 5, which is less than 0. Therefore, the P that we are looking for is 5, because this one satisfies the condition. Okay? So basically, this is the application of what we have learned. And in further mathematics, this kind of question is very common. It normally appears in the examination. But in further mathematics, guys, you must know quadratic and cubic, because they are the favorite of the examination. Okay, so I'll discuss the cubic later on. Hope that you learned something again, but before that one, let's just go back to our summary. This is what we have learned, that for ax squared plus bx plus c, that this one can be written as, we can transform this into x squared plus b over ax plus c over a is equal to 0. And then the sum is equal to the negative b over a, and the product will be the c over a. Right? Hope that you have learned something in this video. It's a little bit long. That is further mathematics, and you can ask me any question. Just put it in the comment if you want. So have a good day and see you on the next video.